So we're going to take a moment to talk about something that has a fancy name. It's called the constant of proportionality. The constant of proportionality. But it's actually pretty straightforward. In fact, many of you have been solving for the constant of proportionality without even realizing it. So let's create a problem. Create a ratio problem. We'll say for every one table in the classroom. Oop, mess it up a little bit in my writing. For every one table in the classroom, there are 3 chairs. So I want to write that as a ratio, and I could write it as 1 to 3, or 1 colon 3, or 1 over 3. But these are all would be read as 1 to 3. So those are my ratios. And often, to better understand a ratio, we like to write it out in a table. So let's, in my table here, make some places for the different equivalent ratios. So these ratios will be proportional. Notice this pattern. Proportionality, we're creating equivalent or proportional ratios, but the first thing we always want to do is label. So I am going to label table and chairs because we want to be able to come back and look at these numbers and know exactly what it is that they are referring to. So if I have one table, I have 3 chairs. I have twice as many tables. I have twice as many chairs. Notice that's times 2 times 2. So this would be 3 times as many times 3. 1 times 3 is 3. 3 times as many here times 3. 3 times 3 is 9. Of course, this could go on infinitely, though I don't think you'd have an infinite amount of tables. And here's a question. If you have an infinite amount of tables, but you have 3 times as many chairs as tables, is the infinity that stands for the amount of chairs you have a greater infinity than the amount of tables you have? Okay, actually, we're going to take that away and we're actually going to go back to just one part of what I said, which was the fact that you have 3 times as many chairs as tables. Because this number here is 3 times, the second term is 3 times the first term. And guess what? That number, that's the constant of proportionality. It's saying that no matter the ratio, it will constantly be, the second term will constantly be 3 times the first term. And we can write it as an equation, and it should look similar to equations you've seen in the past, which will show you how we would use that constant of proportionality in an equation. So I'm going to erase some of this if it's going to let me. For some reason, whenever I want to erase something, it likes to make it difficult. Let's see if it's working. There we go. Alright, so I'm going to erase this. I'm going to kind of get rid of this part here. And there we go. We're going to write an equation. So since I'm going to have the tables before I have chairs, that's what's going to come first. I'm going to call that my x value because it is independent and the number of chairs I have is dependent on my x value. So I am going to say that the number of chairs, because I have 3 times as many chairs as tables, so the number of chairs I have is going to be 3 times the number of tables I have. So that would be my equation, and this would be my constant. You will sometimes see it written completely in variables like this, y equals kx. And in fact, when we have done some problems in the past where you guys have been asked to figure out k, we use that because no matter what, that k is going to stay constant. So, for example, if I were going to substitute in a value, let's go ahead and clear that up. If I were going to substitute in a value, I would keep that 3 constant, but then I could say, well, I'm going to do 3 times, let's choose a number of tables. Let's say 10 tables. We're going to have a party in our classroom. We needed a lot of room. We're going to have 10 tables. So 3 times 10 would mean I would have 30 chairs. And that would make sense because 1 times 10 would give me 10, and 3 times 10 would give me 30. And so we know that that would fit in our ratio table. So again, constant of proportionality, really straightforward. It's whatever you're going to multiply the first term by to get the second term. And if your ratios are proportional, it will work for every single ratio. So, you know what? Let's just try one more, but let's make it a fractional constant of proportionality so that you can see that it works in multiple ways. And I want you to get comfortable, again, I've talked about this in the past, with the idea that even if it looks like we're going to divide something, multiplication and division are really the sort of the opposite sides of the same coin, right? If I multiply by a number, that's the same as dividing by its reciprocal. So if I were to, just to give you that visual, times 2 is the same as dividing by a half. Or multiplying by a half is the same as dividing by 2. I want you to get comfortable with the fluidity that we have there. So let me go ahead and again erase that out. Let's think of something that we could have that has a fractional constant of proportionality. Let's say, so that means that the first number has to be larger than the second number. So maybe for every 4 students, the teacher passed out a group worksheet. I think that almost went off the edge there. So we would say for every 4 students, they passed out 1 group worksheet. Remember, we can write this in 3 different ways. And if we have our table, we want to label just students. Very messy. Hopefully you know what that means. Students, and I'm going to abbreviate their worksheets. And then just to add that extra level of understanding in, since students is what we determine first, the number of students is independent, so that's X, and the number of worksheets is Y, depends on the number of students. So if I have 4 students, I have 1 worksheet, and I could then continue figuring this out. If I have twice as many students, twice as many worksheets, then 4 times 1, 4 times 2, 4 times 3, 1 times 3, 4 times 4, 1 times 4. There's that pattern going on there. But the idea is we want to talk about the relationship between the terms, and in this instant, the number of worksheets, the number of reviewing there, is 1/4 times the number of students. So even though it is a fraction, our constant of proportionality would be 1/4. And we could write this out that our dependent variable is going to be always 1/4 that of our independent variable. So if we had 12 students, 1/4 of 12 is 3, we would have 3 worksheets, and we can show that right there in our table. So you guys have shown you how to use equations to find your constant of proportionality, shown you how to use tables. So the next thing that you guys would be learning is how to use a graph. And I'm actually going to leave that for you to use some of your other resources, your videos, your knowledge of how to graph an equation or graph a table, and see if you can identify a constant of proportionality from a graph. But like always, if you have questions and I'm not there to answer, go ahead and email me, or you can message me through the It's Learning messenger, but that doesn't come right to my phone. The emails will come right to my phone.